Let me show you some calculations, some examples how we can calculate confidence interval. Of course, in reality, you will use some statistical programs like R or similar that will do everything for you, but it's important for understanding that you at least try to do it yourself as well. Okay. So remember, this is the case we have two rivers, Vade and Ribe, and then we would like to calculate the average content of chloride in both rivers. The problem is that we can't calculate it exactly because we have no idea what's going on in the whole river. But if our sample is random and representative, we can make an interval estimate. So we can calculate a confidence interval for the average chloride content and then use this confidence interval. Okay. So let's do that. Well, first of all, from the very beginning, we have calculated some statistics. Let's use only Vade. Okay. So we have calculated several statistics, including M, the average chloride content in a sample. It was 152.2. Then we calculated standard deviation for chloride content in our sample. It was 9.3. Then also we know the sample size. We have 10 glasses of water. 10 glasses. So what is the average chloride content in the whole river, assuming that this sample is random and represented? Okay. Well, first thing we need to do is to calculate a standard error, right? So we need to calculate a standard error, which is, in this case, because we are going to use t-distribution, it will be s over square root of n. Okay, so it gives us 9.3 over square root of 10, which is 9.3 over approximately 3.16. This is the square root of 10, which gives us 2.94. 2.90. Okay, so this is our standard error. This is our standard error. Okay. Now we can calculate the t-value. So we need to find a t-value for 0.975 and 9 degrees of freedom, right? So you remember that t-value depends on two things. It's a confidence level and the degrees of freedom, right? Confidence level, we decided to use confidence level 95, okay, 95%. It gives us significance level. 1 minus 95 over 100, which is 0.05. So that's what we sort of will be outside, right? So it's 5% cases where the confidence interval will sort of not work. And then we can take two tails. The left tail is just half of this. It will be 0.025. Then the right tail is 1 minus this value, right? So it gives us 0.975. And because the right tail, it's a standardized distribution, standard deviation is 1, the right tail will be positive and left tail will be negative. But the value will be the same because it's symmetric distribution, okay? In R, if you use R, you should calculate it like this. Q, and then T equal to, then you have this Q function, it's ICDF, right? And then 0.975. And n minus 1 in this case, it's 9. If I run this code, I will get 2.26. So this is our t-value, 2.26. Now, what can we do? We can multiply our sigma to t. So we have t s over square root of n, which gives us 2.26 times 2.94, which is 6.65. Okay, so this is our error margin. It means that we should take plus minus of this value to get the confidence interval for 95% confidence. So let's do that. We have the left boundary, the mu, smallest mu possible, will be 152.2 minus 6.65, which gives us 145.6. I will just round it to 1 decimals. Then the upper, the largest possible value is 152.2 plus 6.65, which gives us 158.8. Again, I will just round it. Okay. So this is my confidence interval. So what it means? It means that we don't know the exact chloride content in the whole river. Okay. But we know that with 95% confidence, it's between the 145.6 milligrams per liter and 158.8 milligrams per liter. If this uncertainty is too large for us, we just need to take another sample, random and representative, and just to take a larger sample size, and then we will be able to calculate it with a better uncertainty. I recommend you to do the same calculations for the second river, for Riba River, and then compare the calculated results with what I'm going to show in a minute. So we have this the results. So that's the statistics we have calculated. This is the error margin. I've got 6.65. I think I just wrote the wrong number here. And this is the confidence interval. This is the confidence interval. And then I did the same for the Riba River. I've got a little bit larger error margin because if you compare standard deviation for Riba, the standard deviation is a bit larger for the sample, and for the size of the confidence interval also a little bit larger. In this case, in Riba, I've got 132.1 to 146.4 milligrams per liter. So that's how to calculate confidence intervals for the average values. And here you have a slide with the sort of main steps what to do when you work with a small sample. Well, first of all, the first thing you need to do, of course, is to investigate what's going on with your sample, how it's distributed. Use different kinds of plot for that. You already know cuckoo plot, you already know histogram if your sample size is large enough. Okay. Check if you have any severe outliers and try to find why you have these outliers. If necessary, maybe redo the measurements and replace them. Or maybe you can think that these outliers are some sort of show the natural variability of your population, and therefore it's important to keep them. Then make a normality test, and then if normality test tells you that the population values are normally distributed, you can use a t-distribution later to calculate the confidence interval. If it's not, then if your sample size is large enough, equal or larger than 30, you still can do it. Okay. Then if we assume that you pass the normality test, you can calculate the average, the standard deviation, then you calculate standard error and the confidence interval. And then you report on the results and make conclusions. Report means you can make an error bar plot and show the confidence interval, or you can just use the numbers and write some conclusions.